Hi guys, and welcome to Unit 2, Lesson 7 Notes on grouping symbols. By the end of the day, you'll be able to solve equations with grouping symbols. Now, grouping symbols are things that look like this. You either have these guys, which we call parentheses. Fun fact, just one of them is called a parenthesis. So this is an open parenthesis, closed parenthesis, like thesis, but parenthesis. Okay, so you have parentheses. You also have brackets. We use these usually if we have parentheses and then they need to go inside more grouping symbols. We use brackets so that you don't get confused. And finally, there are also these guys. Oh, see, struggle. These guys, which we call braces. And if you're a programmer, you will often use these. But we probably won't see these a lot in this class, usually just parentheses. And our key idea is to use what's in the grouping symbols. You want to simplify that first. That's going to be our key idea of the day. So check out what is in your grouping symbols first. Now we're going to put it into practice a bunch of times. So I like visuals. So as I read the problem to you, we're going to draw it out. So say you have a room that is 20 feet long. So your room is 20 feet like this. And then it's 16 feet wide like this. And it's also 10 feet tall. This is not to scale, okay? I'm not an art teacher, I'm a math teacher. Oh, I should have made that a little bit bigger. So here we have that guy. Now this is a whole room. So we're going to do this kind of thing. This kind of thing. There we go. Now that we've got our three-dimensional room. Nice. Let's read the actual problem. It's 20 feet long by 16 feet wide and 10 feet tall. It has a door and two windows, each that are 20 square feet. So its door is 20 feet squared, its window is 20 feet squared, and it's got two of them. If you have a gallon of paint, and a gallon of paint covers 350 square feet, then how much paint do we need to buy? How many gallons of paint do we need? Well, we need to find the area that we're painting. So our area is going to equal the perimeter of the room plus the wall, or sorry, times the wall height. But then we need to subtract the area we don't need to paint, that is the door and the windows, or the windows and the door in this case. Okay. So here we've got the area, and to find the area, we need to first find the perimeter of the room. So the perimeter of the room is going to be the length plus the width plus the length plus the width. But you guys, we're lazy. So it's going to be twice the length plus the width. So it's twice the length plus width, which is 20 plus 16, times the wall height. Well, how tall is our wall? Our wall is 10 feet tall. So that'd be times 10. And then we need to subtract the area of the windows and the doors. Okay. Actually, I don't want to make this blue yet. So the windows and the doors are 20 plus 20 plus 20, because the area of the windows, we have two windows that are 20 each, and a door that is also 20 square feet. Seems about right, yeah. So let's simplify this expression and then see what we have. Now we'll want to simplify this according to PEMDAS. Remember that PEMDAS means we do what's in our grouping symbols first. So that'll give us 2 times 20 plus 16 is 36 times 10 minus, oh, more grouping symbols. 20 plus 20 plus 20 is just 60. So we grouped what were in our grouping symbols, our parentheses. We did that first. Next, we don't have any exponents, so we'll skip it. So next on the list, we have multiplication and division from left to right. So we'll do that first. We'll do this first. 2 times 36 is 72 times 10 minus 60. And we'll do multiplication again. 72 times 10 is 720. Now all that's left is addition and subtraction. So we will end the day, we will end the example with 720 minus 60, and that gives us 660 feet squared. Now that's awesome. That's not the end of our problem though, because that's the area that needs to be painted. Now we know that 1 gallon covers 350 square feet. So I'm going to write a little equation down here that says 1 gallon equals 350 feet squared. Okay. Actually, we're going to divide. We're going to set it up as a conversion. If 1 gallon is 300, oh, go on. Oh my goodness. Okay, if 1 gallon is 350 square feet, then we need X amount of gallons to cover 660 square feet. So we cross we cross multiply because we want to get the X all by itself. We want to get this X all by itself. So to undo that, we are going to, I don't want to highlight in gray, that's going to be gross. We want to undo what's happening to our X, so we're going to times by 660 on both sides. Now, in the end, that will give us 660 divided by 350, which comes out to 1.8857, etc. It's a long decimal, equals X amount of gallons. That's exactly the amount we need. However, you guys, you can't just buy 0.88 gallons at the store. So we need to buy 2. We need to buy 2 gallons. Now, that was a very long explanation for quite a simple problem, wasn't it? It was just a lot of little steps. Okay, so that's using just numbers. But what if you have an equation with a variable inside? Well, if you have grouping symbols involved, like if you have grouping symbols in an equation, the very first thing you need to do is you need to simplify what's inside of your grouping symbols. And then when you're done with that, go ahead and use the distributive property in case you have any coefficients. So we have 2 examples. First, let's simplify what's inside. We can't. Yay. So then we're going to use the distributive property to distribute this coefficient. So we'll do 4 times 3x, and then 4 times 5. So that gives us 8 equals 4 times 3x is 12x plus 4 times 5 is 20. Next, let's subtract 20 from both sides. And that gives us negative 12 equals 12x. Oh no! We're almost done. To get rid, I'm going to undo what's happening to our x. So to undo the 12 times, we divide by 12. And negative 12 divided by 12 is just negative 1. And 12x divided by 12 is plain old x. We get x all by itself. Did we do it right? Let's check. Is it true that 8 equals, we're checking, so it's a question, 4 times 3 times negative 1 plus 5? Well, that's 4 times negative 3 plus 5, And negative 3 plus 5 is negative 2. So is 8 equal to 4 times negative 2? Yes. Yes, it is. We did it right. Super duper. Next. First, simplify what's in your grouping symbols. Ah, they're already simplified. Next, use the distributive property. I think I used a different purple. So 2 times 3n minus 2 times 5. And then we'll do, oh, you guys, we're going to make this extra tricky. We're going to turn this minus 3 into a plus negative 3. And here's why. We're going to take our negative 3 times 1, and then our negative 3 times negative n. So wherever we have a minus, let's change it to plus a negative, because that'll help our multiplication be a lot nicer. Okay, distributive property activate. 2 times 3n, 6n. Plus 2 times negative 5, negative 10. Plus negative 3 times 1, oh, that's just negative 3. That's really nice. Who wrote this problem? Plus negative 3 times negative n. Negative 3 times negative n. You guys, that's a positive 3n. Those negatives canceled each other out. And that's why I like to do the plus and negative. Equals 5. Super. Now let's take our like terms and combine them. We have 6n and 3n. We'll add those up together. And then after that, we'll take our negative 10 and our negative 3 and add those up. Looks like a gender reveal party. That was not intentional. So we get 9n plus negative 13 equals 5. Okay, so we have 9n minus 13 equals 5. What will undo this? Well, let's add 13 to both sides. And we're given that 9n equals 18. We divide by 9 on both sides. And we are left with n equals 2. Did we do it right? Let's check our work. So is it true that I can't get rid of the screen? Okay, there we go. This is going to be a long one. Is it true that 2 times 3 times 2? Get the original problem back. 3 times 2 minus 5 equals 3 times 1 minus 2. Oh, wait, not equals. That's minus. Minus 3 equals 5. Is that true? Well, is it true that 2 times whatever 6 minus 5 is, minus 3 times whatever, well, 1 minus 2, that's negative 1. Is that equal to 5? Well, 6 minus 5 is 1. So is 2 minus negative 3, which is 2 plus 3 equals 5? Yes, sir. Super. So that's the basics of what we're doing. Simplify what's in your grouping symbols first, and then distribute. Okay, we have one more. Oh, my Star Wars fans, it's a trapezoid. So say you have a spaceship that's shaped like a trapezoid. So a trapezoid, remember, looks like this kind of thing. Ta-da! And its base 1, we say, is 7. So this length is going to be 7 something. And then its base 2 is 4. So this length up here is going to be 4. And then its height is 3. So if we had an invisible, like, pew, 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 whatever that is, that's 3. Also, you know, this is a spaceship, so maybe it's got like a little dome here with an alien guy inside. We'll make our alien guy purple. So here he is. He's got little pew guys, and he's in a spaceship, and he's having a great time. And he comes in peace, right? Yay, cool. Take me to your leader. Alright, anyway. So our alien spaceship has these dimensions. Let's plug them into the formula and see what his area is. Watch it fly away to get out of our work zone. Okay, cool. So, what's the area? We don't know. We're trying to find it. Equals 1/2. We're going to keep that the same. Now his base 1 is 7. So wherever we have base 1, we're going to write 7. I'll just use this. And base 2 is 4. So wherever we have base 2, we will write 4. And then the height of his spaceship is 3. So wherever we have the height, we write 3. Cool. Now that this is our expression, let's simplify it. So 1/2, we do what's in our parentheses first. 7 plus 4 is 11 times 3. And then we multiply times 1/2, which you can call 5.5. I like to leave it as 11 over 2. Yay, times 3. That's the same thing as 3 over 1, so that gives us 33 over 2, which is the same thing as 16.5, which is the same thing as 16.5. Any of these answers would be accepted. Ta-da! Ta-da! Okay, so remember to do what's in parentheses first. Basically, guys, follow PEMDAS and do what's in parentheses first. Have a great time on your homework. Oops.